Today we're doing 13-2. It's all about isosceles triangles. That's kind of a hard word to spell. I bet you the word isosceles will be on a quiz and a test. So find it and then spell it correctly. I'm not going to ask you to memorize how to spell. I'm going to ask you to look up the word isosceles somewhere in your test and then spell it correctly. Here's the definition of isosceles. Does anybody know what it takes to be isosceles? Yes.
Aren't they both? Wait, can I just say show you? Aren't like these two like angles are like the same?
You're on to something. Kind of, sort of, yeah. Has to do with the sides of a triangle. Tanner?
Two sides of the same?
Yeah, technically it's actually at least two sides, but yes, at least two sides are congruent. So of the three, two of them have to be the same. That makes it isosceles. If all three are the same, they still could be called isosceles, but we usually use a better word, equilateral, equal sides. Here is some vocab that we need to know. It's going to be very important. I'll use these vocab words in almost every problem. So I will tell you, in this triangle, you may mark these two sides alike, not because we're guessing, just because I'm telling you they are. I have checked it. These are called the legs. Just like you have two congruent legs, hopefully. Not everybody has the exact same length, but most of us do. The legs are the two sides that are equal. So that gets me that vocab word. The base, actually, let's go ahead and write it. Legs, congruent sides. That's how you know which ones are the legs. The base, it's simply the side that's not the legs. Side that is not a leg. We have two legs and then a base. I bet you can guess where the base angles are, because if this is the base, this and this are base angles. There are two, because the base touches two angles. That only leaves one thing, the vertex angle. There's only one angle left, so that means that is the vertex angle. If you remember, the legs are the two sides that are the same. Everything else kind of falls in place. This triangle here, go ahead and I'm telling you that those are alike. That means those are the legs. That means, what do we call this guy here? The base. I did this so I could show you that base does not mean bottom. Many times our triangles do look like this one, and your base is the bottom, but it doesn't have to be. Your base is basically the side that doesn't match. Okay, isosceles triangle theorem. There's one theorem for today. Here it is. If it is isosceles, if it is isosceles, then this is the biggest, most important sentence for the day. If it is isosceles, so if two sides match, then base angles are congruent. Okay, let me pause for a second. I'm going to write a sentence over here. You don't need to write this. My sentence says, if it is 20 degrees, then it is acute. Is that true? It's always true. Let me write this sentence. If it is acute, then it is 20 degrees. Is that always true? Could it be true? Could it be acute in 20? But it's not always true. Does anybody remember what we call this when I take the hypothesis and conclusion and flip spots? Good guess. Try again. It's a type of shoe. Converse. If you take a sentence and you flip it, that's called the converse. This statement was true. Was its converse true?
No.
So can we just take a sentence and flip it whenever we want?
No.
No. If there are times when you can do the converse, your book or instructions will tell you. And this is one case where you can flip it. So I want you to, in your notes, write converse. We're going to flip the statement because it has also been proven to always be true. Your converse is this. If base angles are congruent, if base angles are congruent, then it is isosceles. Not all statements can be flipped and still be true, but this one can be. So it's sort of one theorem, sort of two, because it's the converse. Question number 1. If the measure of the vertex angle of an isosceles triangle is 80 degrees, what is the measure of the base angle? Since it says I have an isosceles triangle, I want you to always start by drawing an isosceles triangle. And label the base. If these sides are alike, then my base has to be this one. The vertex angle is 80. Do we know where the vertex angle is?
Yeah.
Yeah, because if this is the base, this is a base angle, and this is a base angle. That means the other one is my vertex angle. That's up here, and that's 80. Our theorem says if it's isosceles, which it is, base angles are congruent. So if I call this x, I'm allowed to call this x because the theorem says they're the same. What do we know about x and 80? They add up to 180. So let's write down x plus 80. This is called the triangle sum theorem. I think you can do this without a calculator. Go ahead. If we draw a picture, this should help us. I probably would accept this on a quiz or test without work or picture. Number 2, the measure of one base angle of an isosceles triangle is 25. What's the measure of the vertex angle? Let's start the same way. Let's draw an isosceles triangle. Label the base. All right, let's see what the problem tells us. The measure of one of the base angles is 25. So here's a base angle, and here's a base angle, and one of them is 25. If one is 25, what's the other one? 25. They're always the same if it's isosceles. We want to know the vertex angle, so that's our only unknown. Okay, triangle sum theorem says all three of those have to add up to 180 degrees. Should get 130. Number 3. Looks a little bit different. We don't have a lot of words. We have a picture and it says solve for x. Here's what many students do. They see two things and they do this. They just set them equal. Yeah, we do that in math sometimes. We set things equal. Are those two equal?
No.
Well, let's see. Is this an isosceles triangle?
Yes.
Yeah, because two sides are alike, so I'm going to do that. I'm going to label where the base is. If I've got my legs marked, then the other side must be the base. And it is the base angles that match. So if that one's 2x plus 3, this one is also 2x plus 3. And now it kind of falls in the same pattern we've been doing. All three angles add up to 180. Go ahead and write down all three angles added up. Any questions so far about isosceles triangles? If you slow down and label your base, that should help you. I would like you guys to try 4, 5, and 6, and we will go over them in a couple minutes. Label your base every time. Yeah, that actually is that. So it's just 41. Yep, you don't really have to show it. In number 5, X is pointing to this angle. We'll go over them in a minute.
Which one?
5.
Are we gonna do number 7?
We're going to do them all, yeah. All right. Number 4. This is my base. That tells me that these are my base angles, so they're both X. Triangle sum. 3 angles in the triangle add up to 180. And let's see, 70. Number 5. This is my base, which means my base angles match. So X is also 41. Not much work required there. Number 6, since these are my legs, this is my base. So these two will both be the same at 73. Triangle sum theorem, 3 angles in the triangle, add up to 180. What do we get? 34. Questions on any of those? Okay. I'm going to let you try 7, but I'm going to tell you a common mistake before you start. I see a lot of students that do this. I want everybody to look at that and think about what's wrong with that. You're supposed to be thinking quietly. What'd you say? You said it, Cole? You said it? What'd you say?
You're using the side.
Yeah. We cannot add the sides up to 180 degrees. That doesn't work. So why don't you try it on your own? Label the base. See if that helps you at all. This is the base. How did I know that? Because these are the angles that match. So those are the base angles. If that's the base, wouldn't that make these the 2 legs? Okay, well that tells me then that these legs are equal to each other. So the 2x plus 10 leg equals this leg. You can see a lot of our problems look different. Some are sentence form. Sometimes we have angles or sides. But every time we label the base so we know what angles are supposed to match. And if this is the base, then we know what sides are supposed to match. So every problem, label the base label the sides that match the legs. One more. In triangle ABC, angle A is congruent to angle C. If AB equals this and BC and AC, determine the lengths of the three sides. Let's start by drawing a triangle. We know angle A and C are going to be the same. So draw a triangle that has two matching angles, call them A and C. It's called triangle ABC, so that must mean B has to be up here. Okay, that's a good start. Label everything else it tells you. Label where the base is. See if you can complete the problem. Every triangle has three sides. If it's isosceles, it has a base, which I labeled, and two matching legs. That tells me what I'm supposed to do. This side equals this side. I do really nothing with this information. The 4x minus 15, that's just an extra label. If it's a question like this, yes, because we want to know what two legs are equal. Yeah.
Yeah.
Hmm?
So in terms of length of the three sides.
Yeah, so we're not, oh, I guess we will use it eventually, yeah. Yeah, I'm glad you brought that up. So I don't need this side yet because I know which two legs match. But yes, actually we will need that because I have to find the length of each side. So let me plug 10 into each side. 4 times 10 is 40, and 25 more is 65. Plug 10 into BC. 2 times 10 is 20, and 45 is 65. That's good. They're supposed to match. Plug 10 into AC. 4 times 10 is 40. Minus 15 is 25.